Prashant, come here. Prashant. Come here. System you know to operate laptop, right?
I don't know.
What you don't know? I want to move that picture. Mute இல்லனா அந்த இமேஜ் கார்னருக்கு கொண்டு வரணும் வேற ஒண்ணும் இல்ல drag பண்ணி. See yourself will do.
Good afternoon, students.
Good afternoon, ma'am.
Have everyone settled down there?
Yes, ma'am.
Okay. So we were doing in the last class, we were doing one question about finding the percentage composition of a hydrated salt. Were you able to do it at your own? Or rather, you completed that one or not?
No, ma'am.
Why? I think I told you each and everything, and you were just supposed to do the final calculations. So from where should I start again? See, remember, this was the question. There we recalled what are the hydrated and normal salt. Hydrated salts are associated with a certain, yeah.
The screen is not visible, ma'am.
Okay. Can you see the screen now?
Yes, ma'am.
Okay. See, this was the last question we discussed in the class. Right? When we quickly recalled what was the water of crystallization, that a certain number of water molecules which are associated with certain compounds which are already stable. One such example was copper sulfate, as I have mentioned here, right? So we have to solve this question, or rather, we solved this question in the last class. And the solution I have shown you, I just wanted you to understand that whenever a question is related to water of crystallization, you have to take the molecular mass of water molecule as 18. For the elements, you will be taking them as their atomic masses, but for water of crystallization, you will be taking it as molecular mass. I believe the screen is here in front of you, and in my opinion, you were only supposed to do the calculation part of it. The calculation might be bit lengthy, involving more mathematical operations. Nothing else is otherwise complicated in this question. What or how we have solved this question? We have listed the elements, like beginning with iron, followed by sulfur, oxygen, and since it has water, so we have placed water here. Then the mass that combines, it is as per the question. The data given is just kept here, right? Then in the next column, I had written the atomic masses of all the elements. For iron, it is 56. For sulfur, it is 32. And for oxygen, it is 16. Molecular mass of water is 18. 2 plus 16. Then we know what we have to do. In the next step, we have to simply divide the given mass with their atomic mass, and in case of water, we have to divide it by the molecular mass of water. As a result, you will get these numbers: 0.0018, then 0.0072, and 0.0126. Now, for finding the simplest ratio, what you have to do? You have to divide them all by the smallest number, which is 0.0018 in this case, right? So you will get certain whole numbers, and accordingly you will find the empirical formula of the compound as FeSO4.7 water. I believe it is making more sense, or it is more clear to all of you. I will ask the ma'am over there to hand over a mic to students so that we can interact.
Ma'am.
If you have said anything, I'm not able to understand. So please be louder and speak over mic.
Excuse me, ma'am.
Yeah,
We can hear you, ma'am.
okay. Is this, I have asked a question that is this explanation clear to you? So that I can move to the next concept.
Yes, ma'am.
Okay. So moving on, we will, if you have done it in your school, we will just quickly recall what was empirical or what is empirical formula. Empirical formula tells us the simplest ratio between the elements present in an organic compound or an inorganic compound. Both the types of compound can have a empirical formula. For example, hydrogen peroxide we will take up shortly. Now, please remember, it just tell us that ratio. Like if I can say that approximate ratio of the students in the classes, 50% female and 50% male students are there. But what I'm doing, I'm not actually telling you that whether there are 20 boys or 20 girls in the class. I'm just telling you half of them are boys and half of them are the girls, right? Similarly, empirical formula tells us the ratio. It never tells the exact number. Like hydrogen peroxide, it is very widely used as a disinfectant. Whenever you have a ear infection, doctor most of the time prescribes us hydrogen peroxide. As you can see, the molecular formula of hydrogen peroxide is H2O2. That means it has got 2 hydrogen and 2 oxygen atom in its molecule. So the simplest ratio will be HO. That is 1:1. Is it clear to everyone?
Oh, it what by? What by estate?
Is it clear to everyone?
Yes.
Okay. Similarly, another very commonly asked example is of glucose. Glucose, the molecular formula, as you can see, the molecular formula of glucose is C6H12O6. So the simplest ratio will be CH2O or 1:2:2. Sorry. It will be 1:2:1, right? Empirical formula mass can be easily calculated by adding the atomic masses of whatever elements are present in it. So this should be clear to you. Like since you know how to find the molecular mass, to calculate molecular formula mass, finding the empirical formula mass should also be easy for you. If you know the empirical formula of hydrogen peroxide is HO, that means its empirical formula mass will be 1 + 16, that is 17, right? Then we will do this question. You are given, it is similar to what you did in finding the molecular formula. Here again, the percentages of various elements is given to you in this format, right? That percentage of hydrogen is 2.2, carbon is 26.6, oxygen is 71.2. And then you have to determine the empirical formula of compound. For the help or for the sake of simplicity, I have just given the atomic masses of hydrogen, carbon, and oxygen. I will appreciate if you people remember the atomic mass is still 40, right? So please solve this question. I'll give you 3 minutes by my watch. If somebody can has already solved this question, kindly raise your hand or take a mic from the teacher there and tell me the answer. Please solve it individually. Don't make a discussion over there.
Pass the mic, Vetri.
Has anybody got the answer? Your 3 minutes are over. Can somebody apprise me what you have done?
Ma'am,
Yeah.
is it C2H2O4, ma'am?
C2H2O4. Okay. Let's see. That means some of you have at least solved it. What we have to do? We have to make a table like this and then fill the given information. That the first of all, we have listed the elements, their symbols are we have listed, and then the percentage mass, which is given there, right? And then atomic masses. Now then you have to find a number of atoms by dividing the percentage mass by their respective atomic masses. Then the simplest ratio will be found by dividing them by the lowest number, right? So the formula will be CHO2. Now, can somebody tell me where you people made a mistake? Okay, somebody who got the correct answer, please stand up and tell me your name.
And Sai Krishna.
What's right answer?
CHO2.
Ma'am, if anybody has a coordinator, either the ma'am or sir is there, I'll appreciate they can just see the copies of the students, whether what they are able to do, where they have mistakes. Kindly apprise me.
Ma'am, most of them have solved and got the answer as CH42, ma'am. Few they have not simplified, it seems. That is the problem. They have got the correct empirical formula.
Okay. Thank you,
Them have done. Yes.
ma'am. See, the purpose is just to make you understand these questions are very simple, at the same time, very difficult. You have to be thorough with your calculation parts, right? Now, before I give you this question, or I will wish to solve this question with you. The reason being, one point which you people must remember while solving the percentage-based question is that the first step is always add up the percentages, as you can see here. Because sometimes if I give you that amount of carbon is 40, hydrogen is 30, it is not adding up to 100. That means what we must do, we must add this 40 plus 30, make it as 70, right? And then subtract it from 100 to get 30. And this 30 will be the percentage of oxygen. Now the question comes, why only oxygen? Why it cannot be any other element? The reason is pretty simple, that we are living in the atmosphere of oxygen. All of us know the gases present in the atmosphere, most abundant is nitrogen. Nitrogen is not reactive, right? Not as reactive as oxygen is. We are performing all the reactions, including respiration, cooking food. All of them are taking place in presence of oxygen. That means if the sum of the given percentages of the different elements is not making it as 100, we have to add them, subtract the total sum from 100 to get the percentage of oxygen. If it is coming out, say 0.2, 0.3 or 0.5, we can ignore that, because from 0.2%, you cannot make an atom of oxygen, right? So it has to be 1% or above. Fortunately, in this question, the sum is coming out as 100%. That means this compound does not have oxygen, right? So again, the task is to find the empirical formula. Please quickly find the empirical formula. This time it's a simpler, only 2 elements are there. Only 2 minutes are given to you to please find the empirical formula.
Ma'am, CH2, ma'am.
CH2, okay. Most of the students got it as CH2. So there was a purpose of putting these numbers. It cannot be CH2. See, I'll appreciate if ma'am can be with the students there and help them in understanding it.
Ma'am,
See, the first, yeah.
C2H5 correct.
See, C2H5 is the correct answer, but for the benefit of the students who have not got this answer, see, it may at times feel to you that I'm asking so many questions and we are doing so many questions. I'll explain it to you that whatever questions I have put up, every question will be unique or of a certainly different type, right? Book may be having many questions of the same type, but if with every question, you will learn a sub-concept. Here, in this question, if you see, what you have to do, you have to again put the mass percentage of carbon and hydrogen as given in the question. Then you have to divide them by 12 and 1 respectively. The division has to be very clear. You cannot run away with a 0.1 or only up to point division. You have to get it as 6.89 or 6.9, right? Then 17.3 divided by 1 will be 17.3. Now, when you divide the 17.3 by 6.89, you will get 2.5. if you have neglected any number at the first step, that is when you were dividing 82.7 by 12, then and we know that the numbers have to be whole number, and therefore you have to multiply them with such a number that it gets or it becomes a whole number, right? So the correct answer is C2H5. The ratio of atoms is 2:5, and the formula of the compound or the empirical formula of the compound will be C2H5. Is it making sense to everyone? Okay. Molecular formula we know. I don't think there is a need to redo it. We have already done it, mole concept. Simply just a quick recap. It tells you the exact number of atoms of different elements which are present in the given compound. So simply again, another, it is just put up here to tell you that the compounds having
Ma'am, your voice is breaking.
of crystallization can be many. One such example is copper sulfate. Okay. Give me a second. I'll just come back to, I'll just reconnect my system to the. नहीं, अब कुछ नहीं करना। Is my voice clear to all of you now?
Yes, ma'am.
Okay, let's carry on. See, I think from molecular formula onwards, the things you may be facing certain issues related to my voice quality. Apologies for the same, and let's move on. That we understand the molecular formula tells us the exact number of atoms present in a particular compound of different element. Like copper sulfate 5 water will have copper 1 atom, sulfur 1 atom, oxygen 4 atoms, and 5 water of crystallization. So no need to know more about it because we have already covered it. Then we understand how to find the molecular formula. For finding the molecular formula, the teacher or the book wala will give you the molecular formula and empirical formula and this formula can be used to find out the molecular formula, right? So let us do that. Here you have to find the factor N, right? By molecular mass and empirical formula mass, which we have already covered now, right? So we can solve this question particularly easily. The factor becomes N. N becomes equal to 2. N is equal to molecular mass upon empirical formula mass, and that will be 34 divided by 17, making it as 2, right? And this is how you can get the molecular formula of hydrogen peroxide. Since you have got N as 2, you will multiply 2 and the empirical formula of hydrogen peroxide to get H2O2. Is it clear? So, have you understood it all? Students, please speak so that we can move on.
Yes, ma'am.
Okay, quickly do this question. You are given molecular formula of a compound and its empirical formula mass. And you are asked to find the empirical formula of the compound. Just need to do certain calculation based on the formulas. So what's the answer?
Ma'am, the answer is C4H3O2, ma'am.
C4H10 and oxygen.
O2, ma'am.
Okay, let's find out. I think that has to be incorrect. They have molecular formula and empirical formula, in my understanding, has to be the multiple. Let's see what's the answer. See, first of all, we must find the molecular formula mass or molecular mass of the compound, right? So here is a simple calculation. And we will come to the molecular mass as 166. That step, I believe all of you must have cracked and done it, right? Moving on, what we have to do? We have to find the N. Molecular formula mass you have found out, or molecular mass you have found out, empirical formula mass I have given to you, right? So what is the value of N? That is 2, right? So next what you have to do? Simply multiply or divide as per the formula. You were given molecular formula and asked empirical formula. So what you have to do? You have to divide it by 2. So can anybody tell me where you people made a mistake? I cannot hear you if you are saying anything. Please be louder or speak over a mic. I will request the ma'am over there to please give a mic to students so that I can hear them clearly.
Ma'am, they have made some mistakes in the calculations.
Okay, is the mistake clear to them? Calculation mistake, they will understand it with the practice, but have they understood how to solve the problem?
Yes, ma'am, it's clear, ma'am.
Okay. So simply, I'll give you one generalization about what I have understood from all of you. That first of all, always write in the question what is to be solved, and then think what is the formula which is to be used. That will help you. More importantly, one thing I don't, maybe I might have not heard clearly. As you can see, the molecular formula is C8H6O4, right? Now we have understood that N is equal to molecular weight upon empirical formula weight. If it was a multiple choice question, the answer has to be the half of it or double of it. Please remember that, because N will always be a whole number. That is a tip for you to solve the at least multiple choice questions, right? The first step in this question, I'm repeating myself again to you, that first of all, find the molecular mass or molecular formula mass of the substance. Then with the help of it, find the value of N, right? Now after N, you know you are given the molecular mass and you have to find the empirical mass. N you have calculated, so empirical formula will be the half of molecular formula, right? Moving on, sometimes the teacher don't give you the empirical formula. Then what they give? They want the molecular formula, but they don't want to give you the value of empirical formula. What they use is, they say the vapor density. Vapor density is given to you, and this is the relationship between vapor density and molecular mass. If molecular mass is not given to you directly in the question, the examiner must be giving you in the form of vapor density. Is it clear? I'm talking about percentage composition, empirical formula determination, molecular formula determination. In these type of questions, either the molecular mass is given to you directly or vapor density is given to you, right? And by multiplying vapor density by 2, you will get the molecular mass of the given compound. So can you calculate this? Vapor density, it should be oral now. I have put up an easy question so that you are not very disappointed that you are not able to solve so many questions. So if the molecular mass is 44, quickly, what will be the vapor density?
Potato.
Why? What is the formula I told you just before this? I just gave you the formula that molecular mass and vapor density are related to each other. Am I audible to you clearly? Please respond.
Ma'am,
Yeah.
molecular mass is equal to 2 into vapor density, ma'am.
So how, using the same formula, why can't you tell me the value of this?
22, ma'am.
Molecular formula is given to you as 44. Vapor density and molecular mass relationship I have told you that twice into vapor density is equal to molecular mass. We are using the same formula. Twice into Vd, as I say, is equal to molecular weight. So simply using this formula, what we can say that vapor density will be molecular weight or molecular mass divided by 2, that will be 22. Right? Okay. Now, here is a chart of concentration terms. Can you tell me that have you covered them in your school syllabus this year or not? Any one of you, please respond that you have studied these concentration terms or not.
Yes, ma'am. Yes, ma'am.
Yes, okay. I have asked you this question because according to CBSE, they have moved it to class 12. But most of the schools still prefer to teach in class 11. So therefore, what I will do, I will just simply go through the formulas. Practice, we can take it up later, right? So first of all, mass percentage should be very easy and very clear to you. You have done it in class 9th also, right? So what is mass percentage? That mass of solute upon mass of solution, or mass of solution can be written as total mass. That is mass of solute plus mass of solvent, right? So I think this is very clear to you. Then volume percentage. Volume percentage is there, it will be what? Percentage by volume, mass upon total, volume upon volume. Am I audible to all of you? Yes or no?
Ma'am.
I still can't hear you.
Yes, ma'am.
Okay. Mass percentage, volume percentage, mass by volume percentage, they were covered in class 9. I understand these formulas will be very clear to you and you understand and must be able to solve these questions. Talking about ppm, I will just be going through them. ppm is parts per million. They are basically used for finding the percentage purity or the purity of the air in your locality. In ppm, we have to multiply parts of solute and upon parts of total particles into 10 to the power 6. That's the only catch here. Right? For percentages, we multiply them by 10 to the power 3. Now, for ppm, we multiplied by 10 to the power 6. Right? Mole fraction must not have been taught to you, or it is taught, then I can tell you mole fraction is moles of solute upon total moles. Or it can be moles of solvent upon total moles. Important thing which we must remember is that the sum of moles of a solution is always 1. We are talking about a fraction. If you have, let's say, 1 page, divide it into 4 parts, what it will become? It will become 1 by 4 fraction, right? Each fraction will be of 1 by 4. If you add all of them, Some will become again 1 page. So that is very important if you have to solve a difficult question on mole fraction. Please remember the sum of mole fraction of a solution should be 1, right? Most important one here in the list, which are usually asked, are the molarity and molality. We must be very clear about these terms. So let's take them one by one. We describe molarity as moles of solute upon molarity is defined as moles of solute upon volume of solution in liters, right? Now, most importantly, that it is a temperature dependent term. Temperature dependent means that its value is going to change with the change in temperature. Volume of 1 liter of oil. Whenever you purchase oil, please make sure what is written there. Sometimes the carton is have written as 900 grams. They don't tell you in volumes, right? So what do we mean to say here is that volume changes. Like when you freeze water, what happens? Water becomes ice and its volume changes. Therefore, molarity is said to be a temperature dependent term, right? And in that case, it is not very safe to express the concentration of a solution in terms of molarity. So we replace it by another term which is known as molality, right? Molality is moles of solute upon mass of solvent in kg. Now I will appreciate if you can tell me the difference between molarity and molality. I'm not able to hear anything from you, students.
Ma'am, molarity, ma'am, it is number of moles divided by volume of solution in per liter, ma'am. And for molality, it is the number of moles divided by mass of solvent in kg. Ma'am.
Very correct. Good. Molality is written there already, and molarity you have explained it correctly. Both of them you have explained correctly. Now, if I have prepared for a solution by dissolving 4 grams of sodium hydroxide in, say, 40 ml of water, right? Assuming the density is equal to 1 for water, grams per cc. What will be the molarity and molality of this solution? I hope the question is clear to all of you. That a solution is prepared by dissolving 4 grams of sodium hydroxide in 40 ml of water. What will be its molarity and what will be its molality? Have you found the molecular mass of sodium hydroxide or do you need help?
A few minutes, ma'am. We are doing it.
Okay.
Ma'am, a doubt,
Yeah.
ma'am. Ma'am,
Yeah.
what level of H2O, ma'am? It is whether the solution or solvent, ma'am.
Is it solution or solvent? See, how do you define solvent? Solvent has to be a pure liquid. That is water. Solution will be formed when you are dissolving sodium hydroxide into it. So that means pure water. I have given you 40 ml of water. So that is a solvent. Like when you drink milk in the morning, you have say a glass of milk and you are adding 2 teaspoons of sugar to it. That means sugar is a solute and milk is a solvent. But once you mix them, they make a solution, right? Similarly, 4 grams of NaOH, its amount is less. So therefore it is solute. 40 ml of water is solvent, right? I have not given you the solution, the mass or volume of a solution. I haven't given to you. I have given it to you for solvent only. Is it clear?
We don't know. Can you help us, ma'am?
I cannot hear you if you are saying something to me.
Ma'am, we are not able to do it, ma'am. Can you please help us in doing this?
Okay. See, I have purposely given you the question because at times students fail to understand what is to be kept at what place. So let me explain it to you that when you are finding molarity, capital M, right? Moles of solute will be mass upon molecular mass. So what is the mass? And we understand 4 grams of NaOH is our solute and this is our solvent, right? So 4 grams molecular mass of NaOH will be 40. 23 plus 16 plus 1, making it as 40. So the numerator for both capital M and small m is clear. It is 4 by 40. The issue is with the denominator. The denominator in one case has to be mass of solvent in kg. I have given you 40 ml of water. Since its density is 1, it will be simply mass of solvent is what? 40 divided by 1000. Is this part clear to you? Please say yes or no, so I'll explain the molarity term also to you.
We don't understand how 40 by 1000.
The denominator 4 by 40 is clear to all of you? The numerator 4 by 40, is it clear to all of you?
Ma'am,
Yeah.
since it is given in kg, how can we take it for 40 by 1000?
I have given density as 1. So that means 1 gram is equal to 1 ml. So that means 40 ml is equal to 40 grams. If I have to convert it into kgs, 40 grams has to be divided by 1000. Is it clear or not?
Yes, ma'am, now it's clear now.
Okay. Now, coming to the molarity part of it, it has to be total volume of solution in liters, right? So for solvent part, that is 40 by 1000, which we understand now, right? Then 40 ml and 40 gram are equal. Therefore, I have chosen water as a liquid, right? Now talking about, it has to have a volume of solute also. Then there is a catch that please write it down and remember, unless or until mentioned, density of solids is taken as 1. Please remember this. Whenever we are solving questions for competitive exams, it is never given, but we must understand densities of generally solid is taken as 1 unless or until specified, right? So what I have to do here for sodium hydroxide, I will be putting it as 4 grams divided by thousands, because its density is also 1. I'm repeating myself that in case of finding the volume of solution in liter, in this case, we have to know volume and density of solid, that is sodium hydroxide, as well as water is 1, right? 1 gram per cc, to be precise with units, right? So for sodium hydroxide, since I have given you 4 grams, it has to be 4 divided by 1000 to make it in liters. Similarly, for water, it has to be 40 divided by 1000. Is it clear to all of you or not? Dear students, please respond.
I understood the sum, ma'am.
I didn't get you.
Ma'am,
Yeah.
ma'am, for molarity is 2.5, that is correct, ma'am.
I didn't understand what you are saying. I can just hear you, but cannot understand.
Molarity answer is 2.5 is correct, ma'am.
See, if you are solving it, the purpose of me discussing it here was not to make you solve the question. You can solve that. That's very good. But you must remember how to substitute the values, right? And also, the student who has said that they have found it as 2.75 must be correct. But remember, the molarity and molality of the solution will have a separate values. That's important for you to understand. If now, can you tell me which will, for the same solution, if you go on solving, what will have a smaller value, the molarity or molality? I mean to say that if you solve both the values, the molality value for the same solution should be less or more. I will say it should be more, because 4 by 40, that is numerator is same in both the cases, right? So the denominator is smaller in case of molality. Therefore, if you have got, I think I heard 2.75 from somebody. So this value should be 2.78, slightly higher than this, right? Again, 2.75 and 2.78 are the hypothetical number which I have put on without solving them. Is it making sense? For the benefit of all of you, I'm repeating it again, that when you are solving a solution, numerical based on molarity or molality, please read the question very, very carefully. As someone from you asked me that water I have given as solvent or solution, that is very critical. Volume of solution means it is volume of solute plus volume of solvent, right? So that was the purpose for putting or asking this question and discussing this, that be careful. If you are putting the values correctly and not able to get even the, you miss the calculation part or you made a certain calculation mistake, even then you must be sure of getting at least 3/4 marks in your internal assessment. Of course, for competitive exam, I have given you that hint, 2.7 and 2.78. If somebody wants to know which one is the value of molarity and molality, always remember molality of a solution will have a higher value because it has a lower denominator, right? So just I'll ask the ma'am or the students, is the concept clear to all of you?
Yes, ma'am, they have understood the concept, ma'am.
Okay, so we will wind up the class, and in the next class, we'll be doing one more formula related to molarity and molality. Then we will talk about limiting reagents or limiting reactants, and then the chapter will end for us. Anybody has any query, can please post it at a respective place, and most importantly, there is nothing to fear about, madam.
Yes, ma'am, definitely they'll do so, ma'am. Thank you for the session, ma'am.
Don't be scared of this chapter. Chapter seems lengthy, but very scoring.
Yes, ma'am, I will ask them to work down more questions, ma'am. Thank you for the session, ma'am.
Okay, thank you.